All right, we did slope on the coordinate plane, which is really simple, right? This is just you counting on the coordinate plane. That coordinate plane, hilarious, is just a series of number lines, right? Just laid on top of each other. Zeros going out, positives and negatives, or zeros going out, positives and negatives. And when you put that together, we put the line on there, and then we're just counting. That was really easy. Now, what we're really going to do, and this is something that we do as an 8th grader, is we can find slope from 2 points without a graph. And what we're going to do is we're just going to find the difference between 2 points. So we're just looking for the difference between the y and the difference between the x's. And the key for this is the most important part. There's key is pick 2 points and label those points. All right. Now, to kind of equate this to what we were doing in terms of what we were doing in the counting, I'm going to write a different word on this. I have the word difference written here, but right underneath it, I'm just going to write distance. And distance here. And what we're saying is how far is one point from the other vertically, and how far is it horizontally? And then from there, we can determine what the slope is. Now, there's 2 ways we're going to do this. We're going to do it with a table, and then we're going to do it with just 2 points. And you can see that lower down on your paper. All right, so let's use the table first. I'm going to erase this so I have workspace, but you should just work right below it or right around where this is on your paper. That's perfectly fine. So I'm going to erase this. Now, the first thing we need to do is we need to pick 2 points. And from this, what we know is, we know that this column is x and this column is y. Now, I'm just going to make sure that you can see that y. I don't want it to cut off. Good. Okay. And I'm just going to pick the first 2 points. You could pick any point. You could pick this point and this point, this point and this point. Any 2 is perfectly fine. So I'm going to pick the first one, 1, 12, x, y. Then I'm going to pick the second one, 3, 9. Now, this is a fundamental of 8th grade math that you will use next year for sure. And that is slope formula. So over here I'm going to write slope formula. Okay? And that's going to be this, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Get that down. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Now, just so you know, these little numbers here, they're kind of on the right hip of the variable. They have no numerical value, okay? They're just designators to say this was the second point, this was the first point. So up here, when you see my 2 points here, I'm actually just going to pick what they are. It's completely arbitrary too. So I'm going to say this was point 1, and this is point 2. Okay? And then we're going to take the x's from these and the y's from these and subtract them to find the difference. All right, so let's try this here. The first thing I'm going to do, I'm going to use my orange. So I'm going to do my y's first. So this is 0.1, so I'm going to take the 12, and I'm going to put it into y sub 1, and I'm going to take the 9, and put it into y sub 2. So that's going to look like 12, not 12, 9 minus 12. All right, and then let's use this one. Use my light blue. My 1 is in 0.1, so my 1 is going into x sub 1, and my 3 is going into x sub 2. So that means I've got 3 minus 1. Okay, so I'm taking 0.2 and subtracting 0.1 from it. That's what this is saying. Y sub 2 minus y sub 1. The second y minus the first y. X sub 2 minus x sub 1. The second x minus the first x. And then we do the math. 9 minus 12 is negative 3. 3 minus 1 is 2. Therefore, the slope of this table is 3, the negative version of 3 halves. Something wrong with that marker. That's it, okay? This is all about formula and structure. Look, when we talked about the counting part, it's very, very simple. But if you're not paying attention to it, if you're not being deliberate, if you're not making yourself do it right, you're not going to get it. Same thing with this. You're just taking one point and subtracting the other point from it to get this. Now, what's interesting about this is that you should know that when we talk about slope, I'm going to erase this because we're going to go down the page. When we talk about slope, slope is the constant rate of change for our relationship that we're looking at. And I'm actually going to write that down. So where it says, write a word problem for this table, I'm just going to write this here. Slope is the graphical representation of a constant rate of change. Right? That slope is how you can see how things change over time. Now, I had to think about this. Yeah, I'm not going to say that. All right? So you have that in your box. Write a word problem for this table. Now, let's do this last problem here. I've got negative 3, negative 2. So I've got negative 3, negative 2, and then 5, 4. Now, because we're using points, I'm going to write this a little bit differently than I did the last one. When you set this up, label your points. X sub 1, y sub 1, x sub 2, y sub 2. That's not hard. Now we're going to set it up. So my formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. When I write this in, I've got y sub 2 minus x sub 2. Okay. Now, this sign stays always. Second term is negative 2. This sign is not the negative on that 2. This sign is the difference. That's where we started from. The difference between these points, or the distance between these points. That difference has to be there. The difference maker. Oh my God, I just thought of that. I'm a genius. The difference maker has to be there. Then whatever term this is, it doesn't matter. It's still that term. That's our y's. Now we look at our x's. 5, x sub 2, minus x sub 1, minus, there's the difference maker, negative 3. The opposite of negative 2 is positive 2, so that's 6. The opposite of negative 3, that's 8, which means this should be divide by 2, divide by 2. This is one of those ones where I kind of forget. 3/4. So m equals 3/4, which means without even knowing what that line does, I can tell you from that it goes up 3 and right 4. Now, what I want you to do, let me make sure that's on the screen. Good. What I want you to do is, there is a coordinate plane on your sheet. I want you to graph these 2 points, use a straight edge, connect them, and then prove that that slope is 3/4, right? 3, 4. Up 3, I have to think now, which way? Up 3, right 2, up 3, right 2. And what that, or right 4, sorry, right 4. What that means is when you graph that on that coordinate plane here, this is not to scale, certainly not even official. Wherever you start, let's say you're at -3, 2. So -3, 2, 1, 2, 3, 1, 2, about right there. -3, -2. And then what's the other one? 5, 4. I'm just going to say 5, 4 is like up here. 5, 4. Okay. When you connect that line, what you should be able to do is count 1, 2, 3, 1, 2, 3, 4. And then 1, 2, 3, 1, 2, 3, 4. And that's where it is, right? Mathematically, you've proved it. Now, literally, you can prove it on your paper by drawing that line. And that slope, because it's a constant rate of change, will go on forever like that. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2. You got the idea? Forever. Here's the cool thing about it. It will go backwards too. Like, we can do it left to right. I teach it left to right, so it's really easy. But it can go the other way too. A slope of 3/4 is equal to that as well, because the negative divided by a negative is a positive. So I could go down 3, 1, 2, 3, and over 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3. It would go the same way. We're just going backwards. All right. Finish your notes, and we'll have practice for this. It'll be a bunch of problems where you're given, yikes, board attack, 2 points, and then using slope formula to solve. Good luck. Keep up. Good luck.